After the pleasant summer time, we're back to the busy daily work with new live webinar from Ontotext. Today, my colleagues Zdzisława Hristova, a senior software developer at the GraphDB DevX team, and Vasil Momchev, the CTO and the data management and products of Ontotext, are going to demonstrate how to create custom graph views over your RDF data. This also includes some of the highlights of the new version of GraphDB. Before we begin, a few housekeeping items. All attendees are going to be on mute by default to avoid any background noises. You're all welcome to ask questions during the demonstration, and in the end of the webinar, Vasil and Zdzisława will devote 10 minutes to answer them. If, due to time limitations, your questions are not answered today, we'll address them in a follow-up email. Today's session is being recorded and will be sent to all who have registered and later available for viewing on our website. Thank you all for participating today. Now I'm giving the floor to Vasil. Vasil, are you ready to start?
Yes, thank you. Hello, everyone. So on the today webinar, you are going to see how you can create custom visualizations on top of the GraphDB. This is one of the many exciting new features which are available now in GraphDB 8.3 release, which you can download if you register on our website. So what is GraphDB? GraphDB is an RDF database which is compliant with the RDF or J interfaces. The key distinctions of the GraphDB is that the database is very easy to use. It allows you to load tons of data and many billion data sets of several billions, and also it allows you to grow your application from the free version to standard edition to enterprise edition, which supports robust cluster and scaling of the reach. Another distinctive factor of GraphDB is that the database is under active development, so you can check our roadmap and see how many new exciting features are coming. And also, not least, we give excellent support to our community and also commercial clients. So what does it mean, easy to use? Easy to use means to be able to have a smooth experience in taking any structured data, generate RDF out of it. Obviously, sometimes you need to clean and transform the data. You can do this with the OnToRefine interface, which is integrated in the workbench, and later expose it as linked data. So this is really a full path where you start with some data, you do some data modeling, and voila, at the end you have some linked data. At a later stage, you can also load any data sets from the linked Open Data Cloud or any other RDF data sets. Now it's really the exciting thing which we are going to show today, how you can visualize this data and create custom graphs out of it. And obviously this is the way how you can share your idea with the rest of the world. So what is really how you can develop these type of customizations? Based on many actually clients, we have developed the most efficient way how we can control in the easiest possible way the visualizations. So there are 4 different queries which allows you to configure how the graphs are created. The first query, which you are going to see later on the demonstration, is going to specify how the nodes are selected. I say nodes because it's not mandatory every RDF resource to be mapped exactly to one node, so you can create virtual nodes. Another query will determine the type of the nodes in the graph, their size, label, and also some other information about the graphs. So these are all the properties of each node in the graph. Finally, you can control also the type of data which appears for every node as metadata, and it displayed in a tabular format next to each when you click on any of the nodes. And finally, you can also control how the predicates or the vertices are labeled in this graph. So by using these 4 types of queries, you can really solve all the problems dealing with real-world data. Sometimes you have to integrate a custom ontology schema, which does not follow the RDFS label or schema, so you can choose which is the preferred label to be displayed. Often also RDF includes some provenance or another metadata which you want to remove from the current visualization. So by using these 4 queries, you can also control this. In RDF, in order to have NRE relations, sometimes there are relation objects. By using these type of queries, you can skip these objects and you can generate direct links between the RDF resources. Also, sometimes you want to filter some instances based on filters developed with SPARQL. This is also possible. And not least, sometimes not everything is really properly coded with RDF resources, so you can generate RDF resources on the fly. Okay, so before to give to the demonstration to Desiswavo, I wanted to give you a few links which will make your experience today easier. So you can check all the examples and you can also try to repeat them. If you follow on this website, it's actually the GraphDB Dev Hub, and you should find for the graph views. If you have any problems, I can paste this also in the chat. For those of you who don't have GraphDB installed, you can do this now by going to this website, the GraphDB free website, and register and download it. Also, if you want to get some further information about the data visualization and what are the other options to visualize data in terms of integrating other tools, you can check the Vladimir Alexiev's webinar, Building Knowledge Through Data Visualization, or if you just want to see how to generate RDF models from any structured data, you can check the Pavel Michal's exclusive sneak peek in GraphDB 8 workbench where the OntoRefine integration is introduced. So I leave you now in the hands of Desiswavo. She is really a mountaineer, and she will help you to cope with the amount of your data in the organization. So that's it. I give you the presenter role to you, and
so hi from me, I'm Desiswavo, and I will make a short demo about the new features in GraphDB on top of the visual graph that I hope that you are familiar with it since the last version. So I hope that you have some experience using GraphDB Workbench and also the visual graph, but if you don't, still you will understand this demo. So for the purpose of this demo, I will use a dataset with airports, airlines, and routes. It is the open flight dataset that contains over 10,000 airports, and the information is converted to RDF with the OntoRefine tool that is present in GraphDB. So for you, after the webinar, you can check in the desktop of the documentation all these examples, so you can go through them by yourself again if you want to try something, and you can download also the data from there. So in this data set, what we have is a route. So a route has a source, which is an airport, and a destination. So this is a flight from one airport to another airport, and it is operated by airline. So let's see, I have this GraphDB Workbench, which with that repository, the air route repository. So I'm searching for Sofia Airport, and now what I have here is that there is a flight from Sofia, and this flight is going to the Heathrow Airport. So we have a flight from Sofia Airport to Heathrow Airport. So here we see that these routes, URIs, they don't have a meaningful label. You just see these numbers. So that's often the case with RDF data, that we want to see something else from what we have in our actual RDF. So what if we want to ask which are the flights flying from one airport to another airport? So let's see how we do this with SPARQL. So in SPARQL, here is our query. So we have a flight that has a source, which is one airport, and this flight, the same flight, has a destination ID predicate to another destination. So from these two triples, we can infer that we have a flight from source to destination, and in the result, you see that we have flight from one airport to another airport. So what's new in this new GraphDB, you can see here, is the visual button. So the visual button show us graph results for whatever SPARQL graph query you have in your SPARQL editor. So it may be a construct query, it may be a describe query, and you see that these are some airports with and how they are connected. So what if we want to continue exploring this airport? Oh, but now we see the predicates in the data, which are source ID. This is the data in the repository the way it is. But we don't want to see this actually. We want, when exploring one airport, to continue seeing this has flight to predicate. So if we want to do this, we go to the visual graph, and now we will create our first visual graph. So here in the visual graph, you see the easy graph. This is the old version of the visual graph we are familiar with, the basic visual graph. Now we have additional visual graph here, which is advanced graph configuration. And so now here we have to start, we have to choose the starting point of the visual graph. I will show you by example what this means, but for now we will choose that our graph will start with a query and paste here the query that we have written before, and we have seen the results from it. So in order to extend this graph visualization with custom expansion, we go to the graph expansion. But first, let's choose some name for it. So it may be airport to airport. And now in the graph expansion, we choose the same query. So here, there is something which is very important, and when you read the description of the new configuration, you see that the node variable is required. So in order to have expansion, we have in our query to have a node binding. When you expand an instance, a node in your graph, it will replace this node variable. So here I should write the node variable, and each time I expand a node, here this node will be replaced with the IRI, and I will get the Ontotext flight to connection for this node that I expand, and I will obtain the destinations for this flight. So let's see this in action. So I save this and go to airport, and now expand some airports. And now, okay, the expansion works, but what happened with the labels? I will now show you. What happened is that in our new visual graph configuration, you can also choose the way you obtain the types and the labels for the nodes. If you are familiar with the visual graph, you know that different types are represented with different colors. So with this query, we can select how we obtain the type, because the type may not be the RDF type. You may have another predicate for it. But also, we may choose what is the label, because sometimes you may have your own predicate for the label also. So for the ease of use, for each configuration, we have sample queries. So to start playing with the visual graph, it's easier to choose from these sample queries and try to modify them. So I'm using this sample query for the type, label, and rank. And here you see it is a simple select query. So when I have the label binding in my results, I will use the value of this binding for the label for my nodes. So when I save this and go to the airport to airport, now it looks better. I have labels for my nodes and I can expand further the airports. That is nice, but one of the powers of the visual graph is that you can create more than one visualization over the same data. So as I said before, we have in this data not only routes flying from airport to airport, but also we have airlines. So what if what we are asking is which airlines fly to airport? So again, I have one very simple query for you. Okay, so let's go to the SPARQL editor and try to execute this. So what this query fetches from us is if we have a route that is flying from an airport, and this route is executed by an airline, then we can say that an airport has flight from with this airline and the actual airline. So now we will create a graph that has both airports and airlines and see how are these connected. I will again get this query and go and create my second visual graph. So I create second visual graph and I can name it airport to airlines. And now to show you the different options for the initial state, I will choose the default, which is start with a search box. And later you will see what's the difference. So I go to graph expansion and I type this query here, but as I said before, what we need here is the node variable. So we say that we will obtain for an airport will be our variable, which are the airlines that this airport has flights from. Okay, so I save this and go airport to airline. So this is now the difference in the initial state. In the previous visual graph, we selected the SPARQL query results to be our initial state. But now we have the option each time when we load this visual graph to search for a new start resource. So now I can search for the Sofia airport. And okay, again, I didn't choose for my visual graph the node basics. So I get back to the configuration and choose it because I want to see the labels. And then again, I search for Sofia. Okay, so now I can see that Sofia has flights from with American Airlines. Okay, that's nice, but if now I try to expand American Airlines, I don't know with this expand query how to obtain the links for the American Airlines. So in this second example, we have in our visual graph both different types of nodes. We have airports, and on the other side we have airlines. And we have one expand query that has to handle both of these cases. So how are we doing this? So I'm returning to the graph expansion, and then what I say is that I don't want only to obtain for airport the airline, but also I will obtain the opposite, which is for an airline, the airport. Let's see how we do this. So I'm writing a union here, and then I get the same triples, but this time The difference is that the variable will be the airline. So when I click on an airline, here the airline comes to replace this node, and I obtain the airport. The airport, okay. And then when I have this airport binding, I can obtain from here for an airport. I will copy this for simplicity because it is almost the same, but now here the variable, as I said, is the airline. So by obtaining this triple here, you see what happens when I clicked on an airline, I get this airport bound, and I get this triple, the second one. So I get for an airline, which are the airport, and I will not have triples for the first one. I will get only for the second one. So let's see if this works. So now I should have also for an airline, which are the connected airports. Okay, that's cool, but in my example, I also handled because I have a route which is flying from an airport. I also handled in my query also the flights that are flying to some airports with some airlines. So the whole picture is the query is the same, but only we have the other directions of the flights. So what we have now, let's see, for Sofia, is that Sofia has outgoing flight to with Air Canada, and it has both incoming and outgoing flights with just a moment, with American Airlines, and I can further expand and see for each airline which are the airports that this airline flies from and to. So that is nice. With that, you see that with that very simple data, which contain really not many links, we created two different visualizations on top of the same data. But I can do also something more interesting with another data set. So the second data set is the Springer Nature SciGraph data set, which is again open data platform and contains data sources from Springer Nature and key partners from the scholarly domain. In the data is collects mainly information from the research landscape. It has research projects, subjects, articles, journals, grants. But for the purpose of this demo, we'll focus only on a small subset of this data, which is, in this data, we have articles, and each article has a contribution, and a contribution has a published name, which is the researcher that made this contribution. But note here, this is very important, is that the published name is a string. It is not a URI. So we don't have in our data URIs for researchers. And also for each article, we have subjects. So from this way, what we can say from this is that a researcher contributes to certain subjects. So what if we are interested in what subjects are researchers interested in? They contribute to which subjects, and also we may find some correlations. For example, if I'm a researcher, I may find other researchers that contribute to the same subjects as me. We will see how we can do this with the visual graph. As I said, a contribution has a published name, which is a string value. So in order to search for a researcher, this means that we don't have a new array. We can't use the auto-completion in GraphDB the way it is. But I will show you a very nice feature of the auto-completion, which is when you go to the auto-completion, now you can configure the predicates which values are going to be indexed. This means here that the default for the auto-completion is that all values for the RDF label are indexed, and if you search for a value for RDF label, then you will find the URI. Let me change the repository now. So now what I have done here is that I added another predicate, which is published name. This is the predicate for the contribution. So each contribution has a published name, which is the name of the researcher. So when I search for a researcher, then I find the contribution for this researcher. So because the auto-completion takes some time, because when you have more data, it takes some time to build. I have done this before the demo. I have built the index with this new predicate to find. So, for example, here by searching for Declan Butler, you see that actually what I found is the contribution for that researcher. So let's see what we have here. We find that there is this is the contribution for Declan Butler, and it has an article. But what is very annoying here is these IDs. They are not meaningful visually for us. They don't say anything. And you see that articles, they don't have RDF label, contributions also, so we don't know how to present this. So now when my starting point will be now a contribution, because as I said, we are able to find for a researcher what is the contribution for a researcher. And don't be scared by this long expand query, because I will go through it step by step to show you what it does. So I'm creating this visual graph that I promised to you. Okay, so let's see also if I expand the article. I want to show you the data that we have, exactly the raw data in our repository, is that a contribution, an article has a contribution and an article has subject. So as I said, we are going to infer that for a researcher, which are the subjects he contributes to. So I create new visual graph and I name it researcher subject. And I will demonstrate to you the third options for a start position, which is starting with a fixed node. It is very nice to use this during development, because now each time I load my visual graph, I will start from this resource and I may later switch it to a search so that I don't need to search each time for Declan Butler. So I'm going to the graph expansion again, and I will remove the first part because I want to do the expansion step by step, because it will be easier for you to grasp the idea. So now, when we search for Declan Butler, as I said, we find the contribution for this researcher. So we want, for this contribution, we want to convert the string we have for a researcher to convert it to a virtual URI. So we don't have in the database URIs for researchers, but in our visual graph configuration, we are modeling those with SPARQL, because with SPARQL, we can model almost everything as SPARQL result. So now, if we have a node, a contribution with a published name, the name of the researcher, then after that we are binding this researcher name to a new variable, researcher name URI, and then we obtain from the string value a new URI. So let's see how this changes. So we go to researcher subject, and you see we now have the contribution as before, but also it has a link, which is the new predicate we just developed, published name URI to Declan Butler. We don't have this instance, as I say, in the repository. It is a virtual URI. So that is nice, but we don't know how to expand this. So let's get back to the query, and step by step we just configure the way we expand our visual graph. So then again, go to graph expansion. I will then use, for simplicity, the whole query, and I will explain to you the second part. So the second part is a union which is responsible to generate triples when we expand researcher URIs. So when a researcher URI came, we have here the node variable. So this researcher URI comes here, and then we convert the URI to the researcher name as a string, because that is what we have in our data. In our data, we have that a contribution has a published name, this researcher name. Here in the data, we have the actual string value. So we are doing the opposite as before. We are converting the URIs to string values to find the subject that this researcher is contributes to. So when we expand a researcher URI, we have this variable subject bound, and when we have this variable subject bound, here in the construct query we have a triple for this second triple, which is that researcher is contributor for a subject. So as I said, when we expand researcher URIs, now we can obtain the subject. Okay, that is also nice, but in this demo, we also, when we obtain the subject, we want also to expand the subject to find which are the researchers that contribute to that subject. So this is the third part of our query. So in the third part, the node variable is the subject. When we expand the subject, we get the node variable. I'm sure that you are getting it right now. So then from the subject, we obtain which are the researcher names, which are the names of the researchers that contribute to that subject. And then this researcher name, we convert them again to researcher name URIs, but the variable here, we name it in a different way, because only when we have this whole union match, only then we want to obtain triples for researcher name URI 2, that this researcher is contributor for the subject. So you see, when we expand contribution, we get this. When we expand researchers, we get the subject for these researchers, and when we expand subjects, we get the researchers for this subject. And let's see this in action, but again, this time I'm not forgetting to add the node basics. Actually, I will add the node basics later, just to show you what happens now. So let's see. Now the query is a little bit more complicated, so it takes more time to obtain the actual links. Okay, so now we have that Declan Butler is contributor for genetics, policy, politics, healthcare, and other subjects, and also we can find the other contributors for this subject. That is nice, but I'm sure that you notice that here we don't have the different colors for researchers and for subjects, which is very annoying. And we don't have them because in our actual data we don't have RDF types. Researchers were generated as URIs by ourselves. But having the power of SPARQL in the graph configuration, as I said, you have the freedom to model almost everything. So now we are going again to the researcher subject, and let's see what we can do in the node basics to obtain different types for researchers and for subjects. So it's a little bit of a hack now, but for our example, it's just enough. It's perfect. So what I'm doing now is I'm saying that when I have a node in my visual graph, I will obtain the type that way. If my URI type starts with ontotext.com, this means that this is a researcher because that's the way I generated the URI. If it is not, then it is a subject. It is from the SciGraph dataset. Then this is a subject. So let's see. We'll have to again execute the expand query. And we have to see now different colors for the subjects and for the researchers to be able to grasp quickly our data, the generated data. Okay, so now we can find that Declan Butler is a contributor for policy, and we can also find other contributors in that area. And also you can see that when I hover on the nodes, I get the generated strings for their types. So this way I can explore further and find for each researcher what is his or her area of contribution, etc., etc. Okay, there is one query in the graph configuration that I didn't show for you, so I will get back to it. So those of you that are familiar with the visual graph, remember that when you click on a node info icon, you get a side panel with the data type properties for a node. This is the additional data. So now you can extend this by defining by yourself what to see in this node extra. So the node extra is basically a list of property values, property and value pairs. So it is again a simple query that returns for a node, which is the node you click the info icon, property and a value. So what I will use now is, because we have in our data affiliations, and which are normally universities or organizations that a researcher contributes to. So by again finding for researchers which are his or her contributions, we can find in which university or organization does this contributor mainly contribute to. So I'm using this query here, as I said, what is important is that your query should be a select query that returns a property and value bindings. So here, that's what I'm getting. You see, I have the property and value bindings. You have in the info above all this information to help you with configuring this. So now let's see how this works. So now, again, I'm using this Declan Butler. And I have to again expand some notes for him. And maybe find some researchers, just to be, I want to have more researchers in my graph so that I can show you, because this additional data, it is meaningful only for the researchers. So let's see now. So you can see this, I can pronounce his name, but this researcher has contribution to Columbia University. Let's see the others. This doesn't have. This has contribution in whatever this is. It's nature. Let's find something more interesting. Okay. This data in the C graph, it's really not full, but you see that this Lee Altenburg, it has contributions to both Ronin Institute and the KLI, whatever this means. And this one has to New America. And also there is one thing that I want to show you. I will return back to the visual graph configuration in a second. Okay. So, okay. As I said, when we created this graph, we chose to start with a fixed node. But now, because we use it only for development, I can change this to start with a search box. And this way, I can start each time with another researcher. So now, I can search to, I remember his name, Jokorashi, and find his subjects of interest. So you have one graph configuration, but each time you may search for a different node to be your start node. And let's find the subjects that this researcher contributes to. They're less than the ones before. And maybe find the researchers that contributes to ecology also. And yeah, I'm clicking a little bit too fast. So you see that this one is also a contributor for ecology, and his contributions are in Japan Atomic Energy Agency and Nuclear Science and Engineering doctorate. Okay, so that is the basic visual graph configuration. So yes, you can use the old visual graph search through the search box. It is exposed as an easy graph. But if you want to use the power of SPARQL, you can come here and create your graph configuration. So now that's pretty much for me, but we are now open for your questions.
Thank you, Daisy. It was really an exciting demonstration. As you have seen probably in the Q&A window, there were a list of questions. Some of them were really interesting, so it makes sense to highlight them and to share them with the rest of the audience. So one of the questions was, what is the difference between graph configuration and saved graphs? I guess this was the, okay, this is exactly the screen. So, Desi, could you?
Yes, I will answer this question. So, the graph configuration is, it saves the queries behind the visual graph, so it is a fully functional visual graph. And the way that you expand the graph and everything, the difference is that a saved graph, this is like only a snapshot of your graph. It is just the picture of the graph. So a saved graph is only a safe state, safe state of the graph with the nodes and the links, but a saved graph is not functional without a graph configuration, because you won't be able to expand a saved graph unless you don't have the graph configuration. This saved graph was saved with.
Okay. So the next one was, there was a sequence of questions. What will happen if I do not specify an expand query? And actually, could you tell us which are the mandatory queries in order to have the minimal configuration?
If you do not specify expand query, it is written here in the graph configuration. I will show you just in a, you can find in the explanation here. Now, it says that the query is optional, but if empty, the unfiltered object property sample query will be used. This unfiltered object properties is gets all the links incoming and outgoing to your node. But these are just all the triples which are going from and through the node. So if you do not specify expand query, you still have the expand action, but with the very basic query.
Okay, thank you. So while we are speaking, we got another one. How good would be GraphDB in terms of performance if data volume is huge? Any size limit like 1 million? May I take this one? So actually, 1 million is probably not a huge size. We consider this as a small data set. Maybe if it's a 1 billion, then it becomes a significant size. So the graph visualization has no limit on the size of the data, as long as the database engine can query with the SPARQL the information and it returns it. So keeping in mind that all the indexes in GraphDB have logarithmic complexity, so you should increase 10 times the size of the data in order to have to see some performance degradation. So as soon as you do some sensible queries which results in a how to say, predictable time, then you should be fine. And obviously, the other limitation in terms of the size of the graph you can visualize is the limitation of the web browser. Obviously, if you try to render billions of nodes in the web browser, you run out of memory. But still, you see, it's a gradual expansion, so you have to click really for some quite long time in order to reach this number of nodes on the diagram.
I also want to add something that, as the field said, since browsers cannot handle such huge amounts of data, we have in our visual graph, that's because we changed the repository, we have here in the settings maximum links to show. These are per node. So when I click on a node here, I can say how many links to visualize. And there is a maximum here, so you cannot render an infinite number of links. So it's not sensible, because from our experience, even if you try, even if your browser allows you to render so many links, from one point, you don't see anything meaningful when you have so many links. So you have to choose some sensible maximum links. And it's better to make your queries more specific to obtain what you really are interested in than to try to visualize so many links.
Okay, so even if you have a very odd topology of the graph, the visualization will not allows you to break it so easily using this maximum limit per node. So another interesting question was, is it possible to visualize remote data? And this was really an interesting one. So I can also answer it. Probably there are two ways how you can visualize remote data. So the first one is to use the remote locations. So this means if you run a GraphDB server hosted somewhere else, you can configure a remote location and to connect to it. The other option is to use the SPARQL service clause, which is basically the SPARQL federation, and it allows you not only to query remote data, but to do remote joins. Obviously, this should be used carefully because the performance of the SPARQL queries may be severely affected if you try to do remote joins. And the final question, which I really want to highlight, is it possible to use the graph settings from the old visual graph in the new visual graph visualization? Probably the answer here is relatively easy. You don't have. So the standard flow of usage is you try the easy graph, you decide to, if you check if this works in your scenario, and if you want to modify something, you go to the advanced configurations and you do custom visualization and custom mapping, how the displayed graph is mapped to the actual SPARQL data. So I don't think we have more time for questions.
Well, thank you very much, Slava and Vasil, for the insightful talk and the live demonstration of this exciting feature of GraphDB 3. I want to thank our attendees in the live session today. I hope you enjoyed it. And for those who joined after we started, this webinar has been recorded and will be available in a few days. And if we provoked your interest, head to our website to download GraphDB 3 and start configuring the graph visualizations with the powerful SPARQL language, so we'll be able to see your data from all the perspectives you wish and reveal further relationships. And finally, after we close the session, a very short survey will be launched. We kindly ask for 5 more minutes of your time to fill it. We love feedback and we will highly appreciate it. And have a nice weekend all.